Hi guys, welcome to video 3. This one will not be as long, I promise. We covered a lot of stuff, so I feel slightly justified in making it last this long, but that's okay. We're here, we're learning. You guys are listening to this stuff and trying different things on your own, and that's what it's about. So we ended with this problem. We're trying to add all the terms from 1 to 95 in this sequence and then add them all up, sum them up. What we learned, what I left you guys with was, because this is a linear function, our variable to the first power, no squareds, no square roots, no divided bys. It's a linear function. That makes it an arithmetic sequence and an arithmetic series because I'm adding them all up. And we have our sum formula. We got our sum formula in that last video. Sn equals n over 2, a1 plus an. Looks like that. So to make this happen, to add these up, I don't want to have to plug in every single one and jam my calculator up. We just need to know how many there are. We know what the first one is, and we know what the last one is of our series. Okay, so we can make that happen. How many are there? Well, if I'm going from 1 to 95, there's 95. N is 95. That's easy enough. Okay. I wrote down the common difference. I didn't need to, but by looking at this, the common difference is always the slope, how much it changes by. It's actually not in our formula unless we use that other version. So I wrote it down just in case, but we didn't need it. Okay, to find the first a sub 1 now, the first term of our sequence, we plug in the lower limit of summation in here. It's a 1 here because it's the first term, but sometimes it's not going to be a 1. It's called a partial sum when we start in the middle somewhere and add just some of the ones at the middle maybe. So I'm going to plug in the lower limit to find a sub 1. I'm plugging this one in, and it'll be a 9. Right? I plug in a 1. 2 times 1 plus 7 is 9. Okay, then we have to find the last term of the sequence. To find the last term of the sequence, we plug in the upper limit of summation in there. So 2 times 95 plus 7, make that happen, 197. Now we have everything we need for either one of those formulas. I gave you the alternate version or the other one. Up to you. I chose to do the regular version because it's the most famous one. How many there are over 2 times the first one plus the last one. Right? That's what Gauss did. He added the first one and the last one and multiplied it by how many there were. Okay, not too bad. Okay, last problem then for our sequences for the week. It says to find the sum of, this is a partial sum now because I'm starting from going from 4 to 64. Okay, we should be thinking along the same lines. I need to know how many there are, the first one and the last one. Now a lot of you are going to look at this and think, okay, if I'm going between 4 and 64, there's 60 terms. Super common mistake. There actually are not. There's 61 terms. And to prove it to you guys, let's do smaller limits of summation. So instead of going from 4 to 64 and figuring out how many there are, let's do from 4 to 7. Okay, so we would plug in a 4, and that would be one of them. Then we'd plug in a 5. Then we'd plug in a 6. Then we'd plug in a 7. Okay, there's actually 4 terms. When you guys see this, you're going to want to subtract and say, oh, there's 3 there. There's 3 in between them. But we're not counting 4 when you do that. You're actually plugging this one in. And it doesn't work that way when it's a 1. When it's a 1, your mind does perfect. Your mind says, oh, if I'm going from 1 to 7, there's 7 of them. And there are. Okay? But we can't just subtract them. If you just subtract them, you're always going to fall 1 short. So that's what I put here. If the lower limit is not equal to 1, if it's any other number but 1, there's going to be 1 more than you think. Okay? So going from 4 to 64, you're going to think 60, but there aren't. There's actually 61 terms there. Okay, so there's 61 terms. To find, the common difference is 2, if you want to use that other version. To find the first term of our specific sequence, we're plugging in the lower limit of summation. Okay, I know it's first term of the sequence, you want to think plug in a 1, but it's not. We're going to plug in whatever the lower limit of summation is. So I'm actually finding the fourth term of the actual sequence. It is the first term for what we're adding together. So I'm plugging in the lower one, I get negative 2. I plug in the upper one, I get 118. And then we can put it all in that formula again. How many are there? 61 we talked about. The first one of our sequence, the last one of our sequence. Add them all up, divide by 2, and we're dancing. We're adding terms together. We're working on sequences and summation notation. Here are some suggested problems. Go through and do the ones you can do. I mean, I would suggest being able to do all these. You want to be as smart and prepared as possible. You should be able to do all these. If you can't, there's all kinds of opportunities for you to come see me, office hours or email or whatever you need to do. Look on the internet. There's a bunch, but become familiar with these. Okay, you'll have your problems to upload for the week, some even ones, and I can walk you through those. You have your challenge problem of the week, and that's it. Week number 6, right? We have 6, 7, 8. We're almost there, guys. Just sprint here at the end. You want to lay down. It's the end of the race. I'm tired. Well, don't. Work your hardest at the end, and then you can rest when it's over, when the race is over the summer. Okay, you guys, stay healthy, stay safe. Peace.